All right, welcome to the R1 video. The goal for R1 is to simplify rational expressions. So before we get too far into this is our first experience with rationals and rational expressions. So I just want to be very clear about something. Here, whenever I see the word rational, in my own made-up Stevens math language, I change that in my mind to say the word fractional. All right, so rational really just means fractional. All right, so here we are. We're going to be dealing with fractions. Okay? Now, these are fractions where you're going to have variables involved. So there's going to be polynomials in the numerator and the denominator of these rational expressions. So when it comes to simplifying rational expressions, our goal is to factor both of the numerator and and denominator, and then we're going to see what cancels. Okay? So really two big steps when it comes to simplifying rational expressions. We got to factor. Boy, I really hope that we spend a lot of time factoring, because factoring is going to be one of the biggest skills that you use all throughout math. And we've been doing this since your freshman year in AG2. I know we touched on it a little bit in AG1 with the greatest common factor. In AG2 we did a little bit of this, and now in AG3 it's a whole lot of factoring. So just make sure that you're comfortable and confident factoring, and this is going to be a very easy unit. All right, so let's go. Here's our two steps, right? Factor the numerator and the denominator, and then we're going to see what cancels. All right, so let's hop to a few examples. Let's see what happens if we have a monomial like 36x to the third divided by another monomial. Let's call it 42x squared. All right, well, sometimes what you could do, since I have a monomial divided by a monomial, so here I just want to make note, you don't need to write this down, monomial divided by a monomial, right? How can I factor a monomial like this, right? Well, sometimes it's good to see it when it's all spread apart, how easy this can really be. So 36, we know that 36 is 6 times 6, right? And we have a negative in there, and that's okay. And then x to the third is x times x, right? And then the denominator, 42, well, let's see, 42 is 6 times 7, right? And x squared is x times x. So now we can kind of take a look. Well, what matches in the numerator and what matches in the denominator? So I have a 6 over 6. And as we know, a 6 divided by 6 is 1. A lot of us think that 6 divided by 6 is 0, and that's just being silly. 6 divided by 6 is 1, so I'm going to cancel those 6's out. 6 divided by 7, there's nothing nice about that cancels. X divided by x, that's going to be a 1. This x divided by x, that's going to be a 1. And now I can see all my leftovers. I have a negative 6x in the top, and the bottom is just simply a 7. And I'm done. So whenever I have a monomial divided by a monomial, I'm just going to spread this thing out as much as I can, right? So 36 we know is 6 times 6. X to the third is x, and x. 42 was 6 times 7, and x squared was x times x. And I find my matches, cancel those out, and then I see what I have left over. Let's try one more of those monomial divided by monomial examples here. What happens if we have 15n divided by 30n to the third? Well, okay, so this is going to simplify, and we could get 3 times 5 times n. And in the denominator, this is, 30, so we get 3 times 10, and really 10 is 5 times 2, right? N to the third, well, that gives me 1, 2, 3 n's. Now we got to see what cancels. Well, 3 divided by 3 is gone. That's 1. All right, 5 divided by 5, gone. That's 1. N divided by n, that's gone. Again, that's 1. And I have nothing left on the top. Well, since I don't have anything left on the top, what did everything divide to? Well, 3 divided by 3 was 1, right? 5 divided by 5 was 1. N divided by n was 1. So what I have left on top is a 1. So if there's nothing here, it's really a 1. And then in the bottom, I have a 2n and an n. So I have a 2. Now, n times n, we know, is n squared. All right, let's see what happens whenever we have like a binomial here. So let's take this one down. Let's take a look at another example. Got a few more examples that I want to go over. So let's take a look at 15a minus 3, and we're going to divide that by 24. All right, so here, now let's pay attention. I have a binomial. Again, you don't have to write this down. I'm just doing this to reference, divided by a monomial. Monomial, right? Okay, so 15a minus 3. How can I factor 15a minus 3? And if you're thinking greatest common factor, you're in good shape, right? So GCF. All right, the first rule of factoring, always and forever, is the greatest common factor. So what do 15a minus 3, what do they both have in common? Well, they both have a 3 in common. And whenever I pull a 3 out of each one of these, well, 15a divided by 3 leaves us with a 5a. And negative 3 minus 3 is, or divided by 3, excuse me, is a negative 1. All over. Well, now, do I really need to go through all the factors of 24? No, I do not. I want to do the factors of 24 that are going to possibly match with something in my numerator. Well, since 24 is a monomial, there's no way I'm going to get 5a minus 1 out of the deal. So let's see, does 24 divide by 3? Well, it sure does. So I get 3 times 8. And now I clearly can see the 3's are going to cancel, and now I'm left with 5a minus 1 all over 8. And that's as far as I could take it. All right, let's try another one here. Ooh, step it up a little bit. Here I have x plus 6 divided by x squared plus 5x minus 6. Now here I have a binomial divided by a trinomial. Again, I want to factor first and then see if I can cancel anything. So x plus 6. Can I factor anything out of x plus 6? Well, that's a big resounding no. There's nothing that there's no greatest common factor here at this binomial, so I can't do anything with it. So I'm left with x plus 6. And now with this trinomial, I'm going to go over here on my scratch paper, my scratch work off to the side. X squared plus 5x minus 6. And I'm going to see if I can get this to factor. Now the only possibilities for x squared gives me x and x. And then I have 1 and 6, 2 and 3. Now, as always, my suggestion is to start with the ones that are closest together. But my hint is look at the numerator. Here I have an x plus 6, right? So let's go ahead and instead of starting with 2 and 3, I'm going to be really smart about this, and I'm going to use 1 and 6. 1 and 6. Now, I know my signs have to be different, and I know that I want the 6 to be positive, so I'm going to go ahead and put that there, and I'm going to put the minus sign there. Now, let me just double check to make sure, because I don't want to factor incorrectly. The last thing I want to do here is factor incorrectly. So here I have x times a positive 6 to give me 6x. Negative 1 times x is a negative 1x. Negative 1 plus 6. When I add down here, I get a positive 5x. Hey, that's what I wanted. So now I know that my denominator is going to give me x minus 1 times x plus 6. And now I need to look. Is there a factor that cancels? Well, here I have x plus 6. Notice I just put those in parentheses to let you know this is a whole entire thing. And then I have an x plus 6 in the denominator as well. These are going to cancel out to 1. And now I'm left with 1 divided by x minus 1. We got time for one more. All right. So I just checked with our boss here. We do have time for just one more example. Now what happens if I have a trinomial divided by a trinomial? All right, so let's take a look. We have x squared minus 11x plus 18, okay, divided by x squared plus 2x minus 8. Okay, so again, off on my scratch work, I need to factor these guys. So x squared minus 11x plus 18. The factors of 18 are 1 and 18, 2 and 9, 3 and 6. The only possibility for x squared there gives me x and x. Now I should start with 3 and 6. However, I need to get to 11, and 3 plus 6 is 9. 9 plus 2 is 11. So I'm going to go with 2 and 9. Same sign, both minus. And now when I check, I get a negative 9x, a negative 2x, negative 2, and a negative 9 is negative 11x. So here, these are my factors of the numerator. So whenever I simplify on my next line, I'm going to put x minus 2 and x minus 9. And now I need to factor the denominator. Here we go. I have an x squared plus 2x minus 8. I get 1 and 8, 2 and 4. Now, the factors of 8 that subtract the 2, well, 4 minus 2 is 2. 8 minus 1 is 7. So I know then that I need to try the 2 and the 4. So x, 2, and 4. And I want the bigger to be positive, so I get x plus 4 and x minus 2. When I check here, I get 4 times x is a positive 4x. Negative 2 times x. Negative 2 plus a 4x is a positive 2x. And that's what I wanted, was a positive 2x. So now these I know for sure are my factors. So then I get x minus 2 and x plus 4. And now I can see clearly the x minus 2's are going to cancel. And I'm left with x minus 9 divided by x plus 4. Now, some people are going to look at this and say, ooh, well, those x's are going to cancel too. These x's do not cancel because it's a binomial divided by a binomial. They do not cancel because it's a binomial divided by a binomial.